Now you will remember when we talked about stacks that I wanted to look at how we could parse LaTeX or TeX. Today we're going to talk about trees, and again we're going to be parsing something. But this time it's not TeX, this time it's math. So we're going to work on parsing mathematical equations, and we can do so with the help of trees. So what is that going to look like? Well, in any mathematical expression, we have a bunch of numbers. We have usually some parentheses. We have some operators, and these operators, they can be unary operators or binary operators. Maybe you also know some ternary ones, but I don't think I do, so we'll leave those out. And then we have, well, basically these things, right? So numbers, parentheses, unary operators, and for now let's limit ourselves only to the minus sign as a unary operator. So taking the negative version of a number, and the square root. And four operators for binary operators, plus, minus, times, and division. And the question that we ask, giving a math expression, is what number does it evaluate to? So here we go. Should be the easiest question of today. Here we have one. Please tell me what number this evaluates to. And let's see. Good. Most of you can do math. So 8 minus 4, that's 4, times 2. 8, okay, 8 divided by minus 4 plus 3, minus 1. 8 divided by minus 1, that's minus 8. Okay, good. We can still do this. Most of us can still do this. Good. Now, another way to think about this is in terms of what we call a parse tree. And that thing looks something like this. For every operator, we split the expression into two parts. So for instance, the main operator of this thing is the division operator. So that becomes one part of the tree, and then whatever is to the left of this operator becomes the left part of the tree, and whatever is to the right becomes the right part of the tree. And why would I do this? Well, I would do this so that I can make it into a thing, an expression, something that my computer can operate on. And we see that all of our binary operators have two of these links, the multiplication as well. And unary operators, the square root of 16, and also the minus in minus 4, have only one link. They bring us to only one thing. So this tree represents exactly the same expression. And if we can somehow parse this tree, so if I can somehow tell my computer how to handle this thing, I can find the solution to any equation written in such a form. And I think it's going to be one of the last things I tell you today, after we've seen all the build-up, how we can actually parse this thing and get to the right answer. And I'll show you some Python code that could evaluate expressions like this.